Hello everyone. So the next question is mean stack. Okay. So over here in this question, we are given to make this custom data structure, right? So normally we know stack is a data structure where we can perform the push, pop and peek operations, right? Over here we have to implement this getMin function as well. What it does, it retrieves the minimum element present in the stack. So whenever we perform a normal peek operation, it gives me what is present at the top of the stack. Similarly, whenever we want a getMin operation to be performed, it will return the minimum element that is present in the stack, right? So if a data structure can support all these four operations, then we call that data structure, which is customly made data structure, we call that mean stack, right? We have to implement this mean stack. That is our question. So basically what I'm telling you is that, suppose over here in this example, what we are doing is we are pushing -2. So is -2 pushed, then 0 is pushed, then a -3 is pushed, and then we pop this -3. And then when we call this getMin function in our stack, there were -2 and 0. So this should return me a -2 because -2 is the minimum possible element that is present in our stack, right? Now the absolute brute force way of implementing this particular thing is, these things are directly, we have functions to implement them, right? But over here, if we want to implement this at any particular stage, suppose over here we called this getMin function, the contents were -2 and 0, right? So among this, what we can do is we can create another stack over here. We can create another stack, right? And over here -2 and 0 was present. So I create a mean variable over there. I keep on popping this original stack over here, this stack 1, I keep on popping this stack and I keep track of the minimum, and after popping an element I push this in this stack 2, right? So what will happen is, at first 0 will be popped from here and we will put this in this stack and the minimum will become 0. After that this -2 will come, I will pop this from this stack and put it in this stack, right? And obviously my mean will get updated to -2, as simple as that. Now I can return this mean because I have kind of iterated through the whole stack to find the minimum element and I have pushed it in some other stack. But now I cannot maintain this stack, right? Because initially the content of the stack was like -2 and then 0. So if someone performs a peek operation, I should return 0, right? But over here it is -2. So I should not stop over there. I should again pop all the elements and put it in stack 1, right? So if we start popping from stack 2 and put it in stack 1, first -2 will come, then 0 will come. So it will be, stack 1 will be restored and ready for all the normal operations, right? So what I am saying is that for every getMin function, whatever the size of, if there were suppose 5 elements, I need to pop all the 5 elements and put it in another stack and then again put it back to the original stack, right? So for each getMin operation, I am taking an order of 2n time complexity, right? But in our question over here, let me show you, it is told that I have just copied this part. It is said that you must implement a solution with order of 1 time complexity for each function. So basically this getMin function, I should get it in constant time, right? I am taking linear time in order to solve this. But in our question, it is demanded that this operation as well, this getMin operation, this should also be done in constant time, right? So let us understand how we can do it, right? Suppose you might be thinking the first thing that comes to the mind is, I will maintain a normal stack for all the operation and I will maintain a minimum variable in order to store the minimum. Whenever they will ask me to get minimum, I will return this minimum. But guys, this approach will not work. Why? Let us see on this example only. First we push -2 and our mean is updated. Then we push a 0, but this mean is not updated. Then I push a -3 and this mean gets updated. This becomes -3, right? After that I pop. So basically this -3 gets deleted over here. After that I have a getMin function. After this pop operation, I have this getMin function. Now this getMin function, obviously it will pick out -3, but from the content whatever is remaining inside the stack, -2 should have been the answer, right? So only a single variable won't be able to suffice the job, because once the minimum element is popped out of the stack, there is no mechanism for us to know what was the previous minimum, right? So you can understand that once this -3 goes out, this -2 should also have been stored, so that when -3 went out, I should have removed this and still had access to -2, right? So if you apply a little bit of common sense, we can maintain another stack only for this, because -3 would have been at the top. But if -3 was popped out of here, I would pop out of here, and then -2 would have been exposed, because -2 would have become the new top over here, right? So if we maintain a second stack over here and we keep on storing the minimum as it appears, then only I hope you understand that in the top of the stack always my minimum will remain in the stack to top. So this is the approach that we are going to follow. So before jumping to this solution, I hope why the single variable method is not possible. Obviously, if we want to do it in order of one time, we need some extra space, right? So that extra space, first we start with a variable, right? A variable, we won't be able to do it. Then we keep track, we understood that we need to keep track of the previous minimums as well. And the best way to keep track of that is another stack. Because whenever -3 is present, I do not need to look after that what was the previous thing, right? Once this -3 goes out, then only I need access to this -2. So a stack is sufficient, because at all points I only need the top position, right? So this is all the thing. So let us understand how we will do it using a stack, extra stack, how we will be using, right? Suppose I am saying that I will be taking two stacks. One stack will be my normal stack, suppose ST, and the other will be my mean stack, suppose mean ST, okay? Then what I am saying is that I will push this -2 over here, then the 0. As soon as this -2 is pushed, I should also update my minimum stack. Like in the first iteration, I have no elements to compare. So I will just check if my mean stack is empty. Then I will directly put this element, right? No need to compare it with anyone. Then a 0 comes. As soon as this 0 comes, I will compare that with the top of mean stack as well. Because if the new element that appears, which is 0 in this case, if that is the new minimum, I should push it. Otherwise, I should not push it. So at this position also, if mean stack is, if we perform get min operation, -2 will be the answer, because that is only what is stored in the mean stack. After that, we push a -3. As soon as we push a -3, again we check that is the top of my stack greater than this -3. The answer is yes. So I will have a new minimum, so I will push it. After that, there is a pop operation. So in the pop operation also, we need to be careful that as soon as we remove this -3, and if that removed element is equal to the top element of the mean stack, I should remove that as well. Because once -3 goes out, then that -3 is not the minimum. Then the previous element which was there in the stack, that would have been the minimum, right? So as soon as an element is deleted, we should also check that the deleted element is present at the top of the mean stack as well. Because if that is the case, I should remove from the mean stack as well, right? I should remove from mean stack as well. So this was it, guys. I hope the intuition is clear and the logic is clear how we are doing this in constant time. So as soon as this get min function is called, I can directly return whatever is in the top of this other extra stack that we have created, right? So let me quickly code it up, right? Now before moving to the code, let me give you another example to just clarify another situation, okay? Just a small one. Suppose this is the example that I am talking about. Suppose in this example, what do? We have two stacks over here. One is your mean stack, another is your normal stack. So first is the push operation. I push this. Obviously the mean is also updated. Then a -3 comes and the mean is also updated. Then a -3 comes. Now over here, should we include this -3 over here? Because already in the top of -3 is there. The answer is yes, you should. Why? Because if you don't include, for example, then what I will do is I will in this particular thing, I will not include this -3 over here in the mean stack. Then in the pop operation, I will pop this, and as well as I will check if the popped element is present at the top of the stack. The answer is yes. So I will remove this and I will remove this, both of them. Then I will call a get min function. These are my contents. But in the mean stack, in the top, 0 is present, which is not the answer. -3 should have been the answer. So I should put this -3, because if this -3 goes away, then again this -3 is again it becomes the top. This is referring to the previous -3 that was there. So in case of equality, we should still push, right? So that was it, guys. Let us code it up. I hope you are going to pause and try it on your own. So over here also see, we also need to initialize this min stack constructor over here. The object must be initialized inside this, and the stacks that I will make them global because I need to access them inside all these functions. So what I'll make is, I'll make two stacks. So stack integer st is one, and the other one is stack integer min, for example. Let's keep it short. Okay, and inside this constructor I will assign the object to them, new stack, right, and min equals to new stack as well. Cool. After that, in the push operation, what do we need to do? A value is given to us. In my normal stack I will push it, obviously I will push it in my normal stack, and then I need to check two things. First of all is, if my stack is empty, then I don't need to compare it with anyone, because obviously if I try to compare it with the top, then I will get a null pointer exception because nothing is there. What here? So how are you referring to a null object? Like top of the stack will be a null object, right? I cannot compare that. So I will check first if my if my min stack is empty, then I will just go inside. So there will be OR condition. So if this is false, then there can be another possibility when I need to input in my min stack. What is that condition? If my min dot peak, if this element is greater than equals to, I just explained you the equals to, why this is necessary. If the top of the minimum stack is greater than the current value, then my value is a smaller value and I should push that. So min dot push val, right? So I push the value in the normal stack in all cases, but I push it inside the min stack only if any one of these conditions are true, right? After that, let us move to the pop operation. In the pop operation, what we will do? I will pop the element from the stack and then compare that if the same element is present in the top of the min stack as well, right? So I will take a temporary variable where I will store whatever is popped. I have removed this from the main stack. After that, I will perform the check that if this x is equals to min dot peak in the min stack, if that is the top element, then I would pop it from the min stack as well. Otherwise, I will not pop from the min stack, right? This is my pop operation. In the top operation, obviously I need to return my normal stack dot peak, and if I am asked to return the minimum element, then I will return whatever is in the top of this min stack, min dot peak, right? That's it, guys. This was it. Let me just quickly do it. Okay, so this is n, not m. Okay, anything else? Okay, this is accepted, and this will obviously be near to 100%. Somebody has implemented this particular thing with linked list and submitted it, and it was beating all the time. So that is the 100% solution. So this is the genuine solution, which is the best solution, right? This is quite simple, right? Thank you, guys. This is it. You have made a custom data structure as well.